So, hello students. Today we will solve the numericals based on projectile motion. Okay. So on the screen you are able to see one question that is related to the projectile motion. Basically, it is saying that a cricket ball is thrown at a speed of 28 meter per second in a direction 30-degree above the horizontal. And based on these data, we have to calculate the maximum height, and in second part the time taken by the ball to return to the same level, and see the distance from the thrower to the point where the ball returned to the same ground level. Okay, so first of all, if we will start with the, we can say, the diagram, then it will be more easy for you to understand. So the solution, I'm starting here. So first of all, we should draw the diagram. Okay, so y-axis and x-axis, and they are saying that a ball is thrown with some initial velocity that is 28 meter per second. So let's say that initially the ball was at ground. Okay, so the ball was thrown with some velocity, and again it came to the same level, or we can say same ground. Okay, at this point we can say that at point A, at point B. So ball started from the point A, and or we can say the ball was thrown from the point A, and after the motion it again come to the point B, which is at the same level, or we can say the ground level. Okay, in the first point they are asking us to determine the maximum height. Okay, so let me draw the maximum height, what they are saying here. So maximum height is the maximum vertical height. Okay, let's say this point is for example any point P it is. Okay, so this height will be called as H maximum in first question that we are going to derive. Okay, the maximum height. So first of all, what is given here? Given in the question that we will write. What is given? The initial velocity. Initial velocity. कितना दिया initial velocity? That is 28 meter per second. ठीक है, उसके बाद क्वेश्चन में क्या दिया है कि इट इज थ्रोन एट ए डायरेक्शन 30 डिग्री अबव द हॉरिजॉन्टल. तो ये हॉरिजॉन्टल से 30 डिग्री अबव इसको थ्रो किया गया है. तो अगर इसको अब देखा जाए तो यहाँ से अगर हम बनाएंगे इसकी वेलोसिटी वेक्टर बनाएंगे तो कैसा बनेगा? वेलोसिटी वेक्टर, इट विल लुक लाइक, वन सेकेंड, it will be like that, and the angle will be theta here. Okay, and this is velocity u, initial velocity u. Now we'll write the angle, that is the angle given is 30 degree. Okay, so here the angle with horizontal is 30 degree. Okay, so we'll write here with horizontal. So sometimes what they use is to, we can say, make the question tricky. They gives the angle with the y-axis. Okay, so then the upward angle we have to take, like this angle we have to take for that time. For this time we are taking, because they have given us the angle theta is with the horizontal axis, so it will be 30 degree on. Now uh, our task is to determine first one in part A, maximum height, and it is denoted by S maximum. As we know that in case of projectile motion, S maximum is denoted by u square sine square theta upon 2z. Okay, where u is the initial velocity and theta is the angle with the horizontal and z is the acceleration due to gravity. Okay, so now we will put the values. So we will get S maximum equals to the value of u is 28 and sine square 30 degree upon 2 into 9.8. 2 into 9.8. Okay. Now we are going to uh, simplify this one, and the unit will be basically meter because it is the maximum height. So 28 into 28 into sine square 30 degree. The value of the sine 30 degree is half. So basically it will be 0.5 into 0.5, and then it will be divided by 2 into 9.8. Okay. Now we can calculate that what is the value of what will be the value of this calculation. It will be 28 into 28 into 0.5 into 0.5 divided by 2 divided by 9.8. So it will be 10 meter. Okay. So if you will solve it further, you will get x maximum equals to 10 meter. Okay. So first part is done. The maximum height is 10 meter here. Now in the second part, they are asking that the time taken by the ball to return to the same level. Okay. Uh, this time will be, we can say, the time of flight, because the time taken by the ball to return to the same level is, or we can say that at the same ground is basically the time of flight. Time of flight will be, so in part B, okay, they are asking about time of flight, and that is denoted by 2u sine theta upon z. Now we will put the values. T equals to 2 into 28 into sine 30 degree upon 9.8, and the unit of time of flight will be seconds. Now let's calculate 2 into 28 into 0.5 divided by 9.8. Now what we can do here, 0.5 and 2 will be 1. So basically it will become T equals to 28 over 9.8 seconds. So it will be 2.85. If we calculate it, we'll get 2.85 seconds. 85 seconds. So this will be the time taken by the ball to return to the same level. In part C, what they are asking, in part C, they are asking that the distance from the thrower to the point where the ball returns to the same point. Okay. So as we know that thrower is at the point A and the ball is returning to the point B. So what he is asking the range of the projectile, because the distance AB will be the like the thrower to the point where the ball returns is AB, and AB is basically R, and R is what? Range of the projectile. So that we are going to find out. Okay, in part C, what they are asking, the distance AB, that is R, or we can say range. And we know that the formula for range is nothing but U square sine 2 theta upon Z. Now we are going to put the values. So u is nothing but 28 and its square, and sine, if theta is 30 degree, sine 2 theta will be 60 degree. Now the value of z is 9.8 and the unit of range will be meter. R equals to 28 into 28 into the value of sine 60 degree is nothing but it is square root by 3, square root 3 by 2, sorry, and 9.8 is 9.8. Now if we solve it further, we will get 69.28 meters. 69.28 meters. So this will be the distance traveled by the ball from the thrower to the point where the ball again returns to the ground. Okay. I hope you understand this question. If you have any doubt, then you can ask in the comment section.